All right, welcome back. Let's talk about some if-then statements so we can also get this idea in our head. This and loops go together. An if-then is really a condition. We use them all the time. If it's raining outside, I put on clothes that won't get ruined. If it's snowing outside, I put on a hat, those kinds of things. So I want to look at a couple of items here. So first we need to look at the comparisons. So again, equals really is this idea of a double equal, and you'll watch me as I'm typing, I will make these mistakes quite a bit. Not equal to, so exclamation point and equal. So less than, greater than, less than or equal to, and greater than or equal. And we'll work through some of these so you can see what's going on. So what we really want to do is, in a lot of cases here, we're trying to make a decision. So in this case, we're writing a program that looks at a circle that you're going to look at. And so we have an area of a circle, and if we go backwards on our formula, we can actually compute the radius of that. In this case, they also do something else that we need to talk about called an import math function. That import math function gives us pi and some other math functions. We don't necessarily need it in this case. We could shortcut it and just use pi as 3.14, but it's a handy way to do it. So the other piece then is we also get the ability to say, if one condition is true, we do one thing. If it's false, we do another set of steps. So we're going to take a look at some of those. There is also the ability to do what we're going to call multi-ways. So in this case, so something like a grading program, I skim off the top and I say all the grades above an 89 or a 90 or whatever. And then I grab all the B's, then the C's. And in Python, they use something called elif. And I think it's easier when we show you what these are going to look like. So I'm actually going to take a look really quickly at some of our homework. If I can find in my 337 things that I have open here. There we are. So I'm going to delete this really quickly. So this program we're going to start, and it says the first thing we need to do is we probably need to think about the logic of it. But this really isn't an if-then-else problem. So write a program that accepts the lengths of 3 sides of a triangle as inputs. Program output should indicate whether or not the triangle is an equilateral triangle. And then if it is a right or an equilateral triangle, in other words, all of the sides are the same length, then we'd say it's equilateral. If it's not, then it prints out the triangle is not equilateral. And then it actually tries a couple of things when you get there. So the first thing I've got to do is I've got to get a side. So I'm going to say side, and we could do 1, 2, 3. I'm going to do A, and we're going to do an input. Enter side A. So I know I also need to take that input and convert it into some kind of a number format. In this case, I think I can use integers. We're probably not going to put in decimals. So I'm going to do this right ahead of time. So put in my other. And that way it takes whatever I input, converts it to an integer, and says, hey, that's side A. Well, here's in the magic of our copy and paste was a nice treat. I'm going to paste that in 2 more times. And I'm going to go in here and I'm going to edit side A to side B. And side to side C. So now we've got all 3 of our sides entered in, so we can see what's going to happen then. And so now we need to determine if those sides are equal. So let's look at what an if statement looks like in Python. So I'm just going to put this in. I'm going to say this is our if statements. You don't have to have this in there. I'm just putting it in so we can see what it looks like. So it starts out with an if, and we have to have a condition that is going to be true. So if side A, and notice it gives me these little shortcuts, which is kind of nice, is equal to side B. So picture our triangle. We're measuring two sides and we're saying they're equal. Well, for us to have a triangle that is equilateral, all three sides have to be the same. So I'm going to put in an and in here. So and this condition has to be true. So side B has to equal side C. All right. Well, now you're thinking, hey, you compared two sides. So I said side A to side B and side B to side C. But what we're really saying in there, if side A and side B are the same and side B and side C are the same, then this actually will allow us to see all three sides. And I know it's a little strange. Maybe I should draw it up, but hopefully you understand that. You could implicitly ask for, is side A and side C the same? And it would work the same. So I'm going to print then, and here's where my copy and paste is really a nice touch. I'm going to go over here so I have exactly the right phrase so that our program doesn't hiccup. So the triangle is equilateral. The other option then, if it's not equilateral, I need to use this else statement. Same format, I hit a colon afterwards, and when I hit return, notice it bumps it out in this indent, which is one reason I don't like the interactive mode. It doesn't show you the indenting quite as easily, I think. So, and then I'm going to print, and again, I'm going to cheat here really quickly, and I'm going to put in there the triangle is not equilateral. All right. And if you're doing it in Python outside, the empty statements and tell me what you're going to do. But for now, I'm going to see if this runs. So I'm going to run it. So enter side A, and I'm going to go 5, 6, 4. Triangle is not equilateral. Okay. So I'm going to run it again. And I'm going to put in values that I know are going to work. So we can do that. So I'm going to do 5, 5, and 5. And it should say then the triangle is equilateral. Perfect. Now, when I look at this, I already see, hey, I need to do something here and make it a little neater. Because I can see that it's, you know, my input is right next to the items I have there. So I can make it a little prettier. See, now it spaces it out. Life's pretty. All right, so I think it works. I'm going to go over here, and I'm going to check this. So I'm going to run checks, and hey, so it tested for 2, 2, and 2, and 1, 2, 3. So now I could submit it. Great, we have 100% in this assignment. All right, so I've jumped into exercise 3-2, and 3-2 has a question, and I think we need to look at it a little bit. Some of you may be a little rusty from geometry many, many years ago. So there is a theorem that says in a right triangle, the square of one side equals the sum of the two squares of the other side. Blah. All right, so let's take a look and see what that means. So I drew a triangle, and pardon me because I'm not an artist by any means, but here we have a triangle, and we know we have side A, B, and C, and what we're saying is that in this case it looks like, or as best as my artistic ability would be, that this angle up here would be a 90-degree angle. In that case, whatever value this squared plus this squared is equal to this squared. Well, we use this formula a lot. If you're in construction, you use this to frame up houses even. So let me jump a text box in there and let's just, so we can look at that. So let's look at these values and let's say that we have A is equal to 3, B is equal to 4, and C is equal to 5. So 3 times 3, so we're squaring side A, is, so A squared is 9, plus B, so 4 squared is 16, and what we hope is that that equals C squared, so 5 squared. So 5 squared is 25. If I add those together, hey, that actually works, and we get a right triangle. If one of these numbers changes, so let's change that to a 2. So we would have then the statement 4 plus 16, and we're trying to ask, is it equal to 25? Well, that's not true, so it would be false, so we'd say, hey, that's not a right triangle. So a couple of things we can do here. So if I still had my code up from the other time, I'm getting the 3 sides of a triangle. And so since I did, I'm going to grab those really quickly. Let's see if it'll let me do that from my, there we go. So I saved those. So when I had done this problem before, we did the other one. So side 1 equals input, and we did the integer of it. So we always like to reuse code. So I have like notepads full of scratch code and other things because I'm a bad, horrible typer, especially when I'm trying to talk at the same time. So that part's easy. We've got side 1, 2, and 3, and you're going to ask it as an input. We need to think about then, how can I do that? So there are a lot of different ways to do this. You could do this all in the if statement, but I think that's kind of ooky for now. So what we might do is set up another 3 set of variables. So we might say like square 1 is equal to side 1. And if you don't remember how to do an exponent, so what you're doing is squaring. So so 2 asterisks, and I take it to the 2nd power, so I'm squaring it. So hey, why don't I use my friend the copy and paste again, and we can do this. So now, after I change that to 2, and that to 2, or to 3, excuse me. So 2. So now I've got those squared already. So I can ask that question a little easier. So now I can create an if statement. So I could say, and let's check, one of the problems with this question, it says I don't care how they are. So we don't know which one is the longest. Now, we have some other tools we could do that, but let's just keep it all in the if statements for now. So if square 1 plus square 2 is equal to square 3. So if that condition is true, then we could say print, again, here's where we do our, so copy, the triangle's a right triangle, perfect. And we could say then else, because if it doesn't pass that test, then we're going to assume that it's not a right triangle. Now, what we're leaving out here, though, is how do I get those compound conditions? Because we want to check every possible combination of this to see if it's actually true or not. So we could nest those, and so the else would then be another if statement. But what we actually do is we have something really powerful, and we can use the or statement. So I could say, or if the square 2 plus square 3 is equal to square 1. So I've got a second condition in there. So now I just need that third condition, and I'm going to leave that part up to you, but we can run it and we can see what happens. Invalid syntax somewhere in my thing. So figure out what I did, which is always interesting. If square, and sometimes I do it this way just to make it a little more, or square 3, and this way I can include them in parentheses so I can block them out. Somewhere in that I have a typo somewhere, I'm sure. So let me look at that really quickly. Aha, so if I look at this really carefully, notice what I did. And I told you, I warned you I would do it, and I did. But your brain looks at it and says, hey, that should be equals is equals, and it really needs two of them. So now I'm going to enter the first side, 3, 4, 5, and it says, hey, that's a right triangle, just as we predicted. Now, it doesn't account for the third model, so you'll need to make sure that you complete this, but you can check for and run it. So you actually will need to make sure you include that third model. So 3 different ways. So think about what takes up square of 3, square of 2, square of 1. So make sure you include all 3 of those pieces in there, and you can run that.